In this illustration, we'll study about the power of a laser pulse. We are given that a cylindrical rod of some laser material is having this length and diameter, which contains 2 into 10 to the power 25 ions per meter cube. And it is saying if on excitation all the ions de-excite simultaneously emitting photons in the same direction. That is the way how laser operates. We are required to calculate the total energy contained in a pulse of radiation of wavelength this. If the pulse lasts for 10 to the power minus 7 seconds, we are required to calculate the average power of laser during the pulse. Here in solution, first we can calculate the total ions in rod, which can be written as ion density multiplied by the volume, which is pi r square L. So here ion density is given as 2 into 10 to the power 25 multiplied by the volume is 3.14 multiplied by your diameter is 0.01, so radius is 0.005 whole square multiplied by length is 5 into 10 to the power minus 2, which is 0.05. On simplifying, this is giving us 7.85 multiplied by 10 to the power 19 ions. So these are the total number of ions in the rod which are excited simultaneously and they de-excite also simultaneously. So here we can calculate the total energy of pulse is equal to total ions multiplied by Hc by lambda. Because Hc by lambda is the energy of one photon and every ion is emitting one photon. So total energy of the pulse we can get 7.85 into 10 to the power 19 multiplied by this Hc by lambda we can write 6.63 into 10 to the power minus 34 multiplied by 3 into 10 to the power 8 divided by 6.6 into 10 to the power minus 7. On simplifying, this will give us 23.55 joule. So this much amount of energy is emitted when all ions emit photons simultaneously in same direction, which is generally termed as a pulse of laser. And if we calculate the average pulse power, then we can write it as total energy emitted divided by the time for which the pulse lasts. So we can write it time of pulse. Here it will be 23.55 divided by, we are given that pulse lasts for 10 to the power minus 7 seconds. So on solving this, we'll be getting it as 235.5 megawatt. That is the result of the problem.